Hello and welcome again to another edition of Lost in Science across Australia on the Community Radio Network and through various other means that you are listening to us. This is half an hour on the radio or whatever else you're listening, where we talk about science. And on this week's show, we've got a special guest. Claire, do you want to tell us who is coming on the show?
We do. We have Krystal de Napoli, who is an astrophysics student. She's a Gamilaroi woman, and she's going to talk to us all about Indigenous astronomy and her research into Indigenous astronomy, and also what she studied in astrophysics, and where you can learn a little bit more about the incredible diversity of Indigenous science as well.
Excellent. And I will be talking about a scary story from outer space. Well, not really. Some Polish scientists found some ants, some gruesome finds of some ants inside a nuclear bunker, and what they had to do to survive their ordeal.
Who, the scientists?
Bunker. No, the ants.
Oh.
Yeah, they're entomologists, so they were looking...
They can handle ants.
They can handle the ants. So, yeah, I'm going to be telling you the story of how the atomic age gave rise to these nuclear-powered ants.
Wow.
So, stay tuned for that later in the show.
For over 65,000 years, First Nations people across Australia have been observing the night sky to inform astronomy, astrophysics, geography, biology, and climate knowledge. To talk about this knowledge and her own research, we have Gamilaroi woman and astrophysics student, as well as CSIRO intern, Krystal de Napoli. Welcome to Lost in Science.
Thank you.
Now, Krystal, start by telling us a little bit about yourself, your background, your research, your interest in astrophysics.
Yep, I think the most important thing to know is I'm just a big nerd. I really love maths and science.
As we said before, this is
yes.
a nerd zone.
This is a nerd zone. Nerds are safe here.
Yeah.
So I grew up in rural Victoria, first in my family to go to university, and so for me this has been a massive, I know it's like a learning experience for everyone because it's university, right? But moving to the city and everything, it's been sort of a bit crazy. So yeah, I started studying astrophysics at Monash, sort of took a chance on something that seemed like it'd be quite exciting for me, and turns out I love it. And so I'm near the end of my degree, thank God. Yeah, and I'm still just absolutely smitten with my studies. I do, quite a bit of research outside of my studies, and so that is on the topic of Indigenous science and Indigenous astronomy specifically. I am biased towards space.
Now, 65,000 years, I mean, it is a very long time. So does this make Indigenous Australians the world's first astronomers?
From what we can see, we have Indigenous Australians have the world's first evidence of astronomy taking place. So we have a lot of oral traditions which we can date back based on what the actual stories describe in terms of geography and astronomical events. So things like meteorite impacts, if we hear about that in a story, we can actually date back that meteorite impact and tell from there. But also we have a lot of rock formations. And so these are sites that are related to astronomy in one way or the other. One in particular is the Wurdi-Youang stone arrangement. It's on Wathaurong country, which is part of the Kulin Nation, so close to Melbourne. And this actually relates to the winter and summer solstices. And this site, I know they're working on an age still, but current projections are over 10,000 years, which would date it as the oldest rock site for astronomy in the world. So yeah,
wow.
Aboriginal Australians seem to be world's first astronomers.
That is incredible. Now, you mentioned the Yoyang site in the Kulin Nations, but can you take us through some other examples of Indigenous astronomy identifying astronomical phenomena and how the knowledge is really applied?
Yeah, awesome. So oh my goodness, as soon as I hear questions like this as well, it's just my brain is flooded with different examples. So I think a really core example which sort of helps, I guess, sort of set the tone and explain, what an oral tradition is and what astronomy can actually tell us about our environment in general is the dark sky constellation of the Emu. And so the Emu is quite popular. People tend to know about that first, and it's for good reason. Essentially, for different Aboriginal countries across this continent, the position of the emu throughout the year would actually tell them quite a bit about what was happening with the emu on the ground. And this was to do with the actual emu egg harvesting season. So knowing when chicks are forming and when the eggs are ready for collection and, but it goes into further detail as well, because it's also telling you about how the environment changes and what the emu does with that, how your own food source will change, how your water sources will change, and how obviously the climate is changing throughout the year.
The emu in the sky, that refers to what we would sort of understand to be the Milky Way?
Yes. So we're quite lucky here in the Southern Hemisphere.
Yeah, that we can see the Milky Way.
Yeah, we have a really good view of it. And it's those dark areas of the Milky Way, that sort of gas and dust that block out a lot of light. That's where we start to get these dark sky constellations. And so, yeah, they're quite common in Southern Hemispherian cultures. But yeah, you can see the emu shape. Its head is the Coal Sack Nebula for any space nerds out there.
I'm sure there are a few.
Yeah, but I love that constellation because to me, it actually looks like an emu. And I think that's why I also think it's a great introduction, because it's something that people can really just go out and see for themselves. And especially if you learn that story behind it, you can go out there and see for yourself oh, okay, I know that the emu eggs are ready for harvest now, or the chicks are forming now.
So depending on the position of the emu, it isn't just, I guess, astronomical phenomena that you can talk about, and there's stars out there, but there's so much on the ground that you can relate to it.
Yeah. And that's a really common thing. So the reason I highlight the fact that, it relates to all these things on the ground is because that's the way Indigenous science was practiced or is practiced. It's not necessarily okay, all our astronomy is in this little box over here and all of our, biology is over here in this little box. Their stories are what they encode the science into. And they do it so that it's quite interdisciplinary. There is everything told in this one story. And so not only is it telling you about the environmental changes, the animal changes, the sky, the way it's changing, but also it's usually told in a story that communicates some sort of moral lesson as well. And so there's quite a lot of information that goes into these stories. And so it's a very different way of doing science than what we're probably used to with sort of breaking up into the different little groups of, all right, I'm an astronomer, but you're a biologist.
Absolutely. Yeah. And I mean, the more challenging problems in our world become, the more we're told and the more the solution is to find diverse teams and to work together, to come up with solutions. So, the future is interdisciplinary, right? We can't keep working in small little groups.
Definitely, especially for quite a lot of those worldwide, global issues. I think we all need to come together, and I think that's a lesson you can really learn from the way Indigenous science is practiced. Yeah, but then we have other examples as well. So we have, these stories which describe crazy things like supernovas, which are the big fiery death of larger stars. And it
sounds terrifying.
They're actually really cool. We're pretty safe where we are. So if any one of these occurs, and Betelgeuse, which is a star that people tend to know by name at least, that should go supernova sometime, maybe in our lifetime, tonight, maybe if we're lucky, maybe in 10,000 years, we'll see. But when it does, it won't necessarily harm us, but it's going to be a very pretty sight in the sky. So there's things like that that's very exciting, and they pop up in Aboriginal oral traditions. That's what we call the stories. But they also, in the same place, are then also seen and described by other ancient astronomers around the world in a written text. And so that's an easy way as well for us to be able to date them back too, because you see that sort of correlation. Yeah, so there's a billion and one examples.
There's a billion and one examples. We've touched a bit on this, but why do you think that this knowledge and these oral traditions are so important now?
I have a couple of different perspectives as to why I think it's important. One of the first one that really does jump out is sort of that correcting of the narrative. I know it's super, super common, and I'm starting to forget this whenever I do talks where I'm I have to backtrack and remember the level in which most Australians are at with their understanding of Indigenous culture. Because most people sort of have this idea that, Indigenous Australians, they were nomadic wanderers. They didn't have agriculture or set homes, I've heard they apparently couldn't count above 4 and the most bizarre, claims. And so that's why I think, for one, educating everyone on Indigenous science is important, because I think it's a different way of looking at the culture, and it will probably increase a lot of that respect. I think, obviously we've had quite a long time of trying to sort of push back Indigenous knowledges. And then the other point is essentially what I was saying before. I think that sort of interdisciplinary, like holistic way of looking at your environment and everything is super important. And I think that's a lesson that everyone can really learn. Just in general, in everyday life. I feel like as well, quite a lot of Indigenous knowledge, it's not only just so applicable, right? So, you know, you're learning something that all of us can see, but we're learning knowledge that's very specific to this continent. A majority of the stuff that we do to this earth and the stuff that we've learned is all coming from overseas. And I think it's really important that we start listening to Indigenous Australians about, you know, for example, right, the fire safety with bushfires. You know, before colonisation, bushfires, at least the evidence from what we can see from actually cutting trees and seeing them, you can actually date back the bushfires and they all start around the 1800s. We don't have stuff really before it. And that's because of those preventative measures. And then also things like we should be looking into sustainable crops that are made for this land, that we don't have to put excess effort into keeping alive because they just weren't made for this country. So I feel like there's so much that we could really learn from Indigenous knowledges, and that's why I think there should be quite a lot of like collaboration and support.
And tell me, how does that passion work in with what you're currently doing?
To me, like astrophysics, right? It's sort of like, I guess, like that natural extension of what Indigenous astronomy is. I like being able to sort of take those perspectives, I guess, into my studies and try and not lose sight of that sort of, I guess, the way of communicating information, right? Indigenous Australians, they communicate in these beautiful oral traditions, these stories, and it's something that's really accessible for, you know, the young ones to the old ones, depending on how you want to explain the information. These stories you can make as complicated or as simple as you want to. But then also, what I'm doing specifically, I'm actually working a lot in the space of this sort of communication. Yeah. I love getting the word out. I love trying to educate the public. And this almost sounds like a brag, but it's not a brag, right? It's to highlight how much people actually value it. If I start a talk, it usually sells out, and it's because everyone's really interested. And it's awesome to me. They have these people come along, be so enthusiastic to be able to talk with them. I love it. And also a lot of the work I'm doing now is helping create content for universities to be able to actually
share that knowledge.
Share this knowledge. So yeah, it really is becoming my life, and it's so funny because it's not necessarily specifically what I'm studying, but it's definitely my passion. So I feel like I'm quite lucky that I get to explore both, where I have that nerdy behind the computer astrophysics sort of stuff, but then I also really get to engage with the cultural astronomy that's really important to me.
And you're doing an internship at CSIRO at the moment?
Yes.
Tell us about that.
So I worked there over the summer last year, and it was a really interesting step into sort of new terrain. So yeah, my background is, you know, like maths and astrophysics. I love space, all that sort of stuff. And so I turn up at CSIRO and I'm learning about granular materials and how to use them in soft robotics. And it was very different, but it was actually awesome. Like I had so much fun with it. And then, yeah, this year I'm back. Had my first day today. Woohoo!
Well done.
And I have a new project, which is really exciting. And this is more using AR technology.
So it's augmented reality?
Augmented reality. So
wow.
It's not quite virtual reality where you have a whole headset and everything is you're feeling around in the dark. But it's some really cool stuff that you can... It's at midpoint. It's really cool stuff, essentially like, you know, shining your camera and being able to make things sort of jump up on your phone that look 3D and you can sort of manipulate. And so we have some potential there relating to astronomy, and I'm so excited because it's like, this time it's like, ooh, it's more based on what I really enjoy. So I'm really looking forward to the rest of this summer and seeing what that can produce for sure.
Now, I'm sure there's a lot of people out in Radioland who would love to learn more about Indigenous astronomy, but might not know where to look. Can you offer up some advice?
Yes. Okay. So first of all, I think a really great starting point is we have a website. So it's www.aboriginalastronomy.com.au. That was created by Dr. Dwayne Harmacher, who's just an incredible person overall. It's so accessible, that website. The information's been sorted into, you know, if you're looking for content. So maybe you want to learn more about, you know, the stars or maybe the sun or supernova in Indigenous astronomy. You can sort by those topics. But maybe you're specifically going, you know what, I want to learn more about Wurundjeri astronomy or Gamilaroi astronomy. And so they have it set out on a map too. And so you can really explore quite a lot of information in a really easy, accessible way.
And locally as well.
Oh, yeah. It's awesome. I love it personally as well because I really get to sort of hone in specifically on like my family's roots of, I don't know, I'm a little bit biased, but it's passionately so. But it's a great website. And then as well for anyone like on social media, we have a Facebook page, which is Australian Indigenous Astronomy. And we also have a Twitter, which is @AboriginalAstro, or you can follow me, which is @Krystal de Napoli.
So, Krystal, can you talk about your current research in Aboriginal astronomy?
Yes, I can. So it's a topic I actually really love. For like personal reasons, I'm focusing on the Seven Sisters, the Pleiades. They are a beautiful little star cluster that pops up right around the world in a number of different astronomical traditions. For me, I've always loved this constellation. My mum was always trying to point it out to me, and I could not for the life of me see it, but I know it was one of her favorites.
So this is like a cluster of stars, and
Yes.
there's lots of stars.
Yes.
And there's not a lot around them.
Yeah.
But yeah, I know the one. I always see it. I'm like, oh, yeah, there they are.
You know, it's a fun fact. I don't know if it's fun. Okay, like keep in mind I'm a space nerd, right? But actually, like the Subaru cars, they're like the Subaru
logo?
Yeah, that's actually the Seven Sisters, or those stars.
Really?
Subaru apparently means I think it's like the word for Pleiades in Japanese.
Wow.
But so very cool. So they
fun
pop up a
fact.
lot, right?
Yeah.
So the Seven Sisters, which I guess is like the colloquial name, but yeah, anyway, the Pleiades, they pop up in a number of Aboriginal traditions, as they do. They're an interesting object. Some of the reasons that they're interesting is because they're in that sort of empty space, and they have that massive constellation of Orion relatively close by.
Yeah.
And the way that they actually go across the sky, it looks like that constellation of Orion's chasing them. And so since Orion looks very obviously like a man, there are a number of stories where they're like, oh, these interesting characters, this crazy cluster full of all these stars that are twinkling brightly, and this very defined constellation.
Defined man chasing.
Yes, which is interesting, because when you start looking at the stories about these stars, all around the world, there are a lot of differences, right? Aboriginal Australia, it's, absolutely like different interpretations right across the continent. But a number of these different places start to describe them as seven women, or seven girls, or seven sisters, it's really interesting. And I think there's obviously that is like a conversation and a half right there. But what makes them quite curious is that a number of these different groups will describe the number of stars changing. So sometimes we'll get like 6 sisters, sometimes 7, sometimes 8. And what I'm currently researching is actually what's happening with that. Like, why do you have that fluctuation in the number of stars? And so
it isn't just because some people need glasses?
No. So it's really interesting, because a number of different, this is a very common theme in a lot of Aboriginal oral traditions. When they talk about the Seven Sisters, we frequently get, depending on whatever object they're called, right? Sisters or animals or whatever. We always hear about, the youngest sister or the youngest object or the smallest object, being harmed or something to happen to help them dim their light. And so this is like a common thing. It's not just, we're miscounting, but actually we're specifically seeing one of them sort of go away and then maybe come back over time. And the reason that might be is because it could be a variable star present.
And a variable star is?
Yes. And so a variable star is a star that changes in brightness, because stars, I know they look like they're twinkling, but actually pretty much majority of stars, they're actually very constant in their brightness. Like our sun. I mean, if our sun was twinkling as commonly, that would probably be very disastrous for life on Earth. But yeah, so they're quite consistent. But we do get this subgroup of stars that actually change in brightness over time. There are a number of different reasons for why this might occur. Essentially, it's just sort of getting colder and getting like dimmer, and then getting hotter and getting brighter. And so, yeah, there is a variable star present in that cluster, which is really interesting. And so it's something that I'm looking into further, and yeah.
Krystal, that is fascinating. I hope that you can come back on Lost in Science and talk us through how your research is going with variable stars and your internship at CSIRO.
Yeah.
But for now, thank you so much for joining us on Lost in Science. And I really encourage anyone out there to head to aboriginalastronomy.com.au and definitely follow Krystal de Napoli on Twitter, because you are awesome.
Oh, thank you, Claire. Thanks for having me.
Across Australia on the Community Radio Network, you're listening to Lost in Science.
I probably spend more time than absolutely necessary watching old movies, and you guys probably put up with me talking about them all the time.
Oh, I didn't even know.
Didn't even notice.
Didn't even know that you spent a lot of time watching old movies.
When we say old movies, what's your era of choice?
Yeah, what's your threshold?
Well, look, it depends. I have a vast collection of physical media because I don't see the point in throwing it away now. I've bought it all. But, you know, like old movies from the 50s and from the 60s and from the 70s and from the 80s and from the 90s. They're all old.
The classics of
The classic hits of movies. But particularly old science fiction movies because, you know, it's interesting to see how people of the past imagined the world of the future. But also because they're just really silly a lot of times and just fun to watch because they're ridiculous.
Sometimes they bang on, though.
Oh, sometimes. Not often, but sometimes. One of the most iconic post-atomic science fiction concepts is that of the giant irradiated monster. You probably come across this idea that something grows massive because it got exposed to radioactivity from an atomic bomb.
As opposed to being
Godzilla.
killed by the radiation.
Well, like would actually probably happen. Yeah.
Godzilla comes to mind.
Yeah, Godzilla. But how about giant insects?
Mothra?
Was it them, the ants?
That's exactly the one I'm thinking of. So radioactivity obviously doesn't work that way. But an early example is a film called Them, complete with an exclamation mark in the title. So it's not just them, it's them. Them. Yeah.
Them ants.
Dim.
How'd you like them
Dim.
ants?
them big old ants.
So this film tells the story of gigantic radioactive ants.
Love
Some would say ants.
You could have made that as a proposal to call it this giant ants.
them.
Some would call them brilliants. Brilliants?
Brilly ants.
Brilliants?
Yeah.
So the ants manage to breed in the desert near an early atomic test site, and then they make their way to Los Angeles, presumably with the intention of eating people. It's not really that clear in the film why people are
Or
worried. They're
because
just gigantic ants.
Maybe previously some other giant ants had put down some chemicals and they were just following the line. As ants are wont to do.
Yeah, maybe they're just following pheromones trails to the
Exactly.
coast. Or they're just looking for water. I mean, they're in the desert, so maybe they just wanted a drink.
It's not great for ants.
So the army gets called in and they don't get to eat anyone. But a scientist at the end says, quite philosophically, he says, when man entered the atomic age, he opened the door to a new world. What we may eventually find in that new world, nobody can predict.
Giant ants.
Well, I mean, that is kind of the point of science, though, isn't it? To predict things, and that's kind of what he should have been doing with his job. But, so, obviously, gigantic ants are an impossibility. They're a biological impossibility. Ant biology doesn't allow them, or any other insects, to grow to car size, and that's kind of the size they were in the film.
Right.
They just can't get that big because they wouldn't be able to breathe enough oxygen because they breathe through their spiracles.
I breathe through my spiracles. Do you?
Since you came along, giant
Insecty
ant.
thing.
So that's not going to be predicted because that's not possible for it to happen. But some Polish scientists opened the door on some ants recently that owe their particular predicament to the atomic age in a way that nobody could have predicted.
What?
So while these Polish scientists were exploring an abandoned facility designed during the Cold War for the storage of nuclear weapons...
Ant-Man flew out.
No, he doesn't have wings.
Oh.
But they did discover a colony of ants that had been locked inside since the bunker was closed.
Wow.
And that raised a whole bunch of questions.
Like, what were they eating?
That is the first question. Well, the first question was how they got in there. So it seemed to be, but they fell down a ventilation shaft into the bunker and then they couldn't get out. So the ants were just stuck in this, nuclear age bunker and they couldn't get out of there. It wasn't
the Queen.
It wasn't actually radioactive. It was just that they couldn't get out.
Yeah, okay.
It wasn't radioactive.
No. That probably would have just killed them. So they should have. What they first thought was, how did they get in there? They figured out, but then they did think, well, what have they been eating while they're down here? While they've been locked in here? So they should have expected to find some living ants and a lot more ant bodies that had fallen down the shaft. And they didn't find any queen ants or evidence of the ants breeding in the bunker. There was just a whole bunch of ants just down in the bunker, locked in.
So there was fresh ants that had just fallen down there.
Well, they thought that some of them had just fallen down and some of them had been in there for quite some time. But there were a lot of dead ants in there, but only about twice as many dead ants as there were live ants. So they found about 2 million dead ant bodies and 1 million living ants. So
they were eating ants.
They pretty much were probably eating each other. So this particular ant they found is called a redwood ant, which is Formica polyctena, which is a very territorial ant found in Eastern Europe, which has a pretty gruesome habit. When they so Eastern Europe gets very cold in the winter, and ants basically don't do anything. They go into their nests and stop.
Bunker down.
Stop. Yeah, they basically bunker down. And there's no food around because it's frozen, basically. So they increase their colony in spring, and they're really super territorial. And they have gigantic inter-colony ant wars to establish the boundary of each colony. So they go out and fight each other and kill each other. And then when the ant wars are all over, they drag all of their dead back to the colony and feed them to the baby ants.
Wow. Someone needs to make a movie about this.
Yeah.
The infants.
The inf ants, that's right.
Yeah.
So the Polish scientists wondered, did the ants in the bunker do the same thing? And it's not all that surprising. Sure enough, they collected a whole lot of ant corpses and discovered about 93% had signs of cannibalism, that the other ants had eaten the bodies of these dead ants.
How hard is it to do a antopsy?
Well,
Autopsy?
They did go into some specific detail. They said, it was a binocular microscope, and they've got all the details. They did a proper, published a proper paper on all of this. Wow. The reason is
they see teeth marks in the end and go, I wonder what did this.
Well, yeah, mandible marks in the ants, and they basically only ate the abdomen of the other ants because that was, where all of the nutrition was apparently. But they were, they're actual entomologists, so what they were interested in was, is this a way that ant colonies can survive when there's no other food sources? And there might be situations where that actually helps with ant survival. And there hadn't actually been any evidence other than their ant wars that, in social insects, they went, we didn't really know if cannibalism was a widespread thing or not, but they've just discovered that actually it is something that ants can commonly do to stay alive, even when you think, well, maybe they should have already died. But obviously this only worked because new ants kept falling down the hole.
Yeah.
Nicely, there's a happy ending to this story. The scientists put a big wooden plank from the floor to the ventilation shaft so the ants could finally get out of their bunker and rejoin their colony on the surface.
Which they marauded and ate all the other ants in the world.
Probably not that bad.
Once you get a taste for ant, though.
That's all we've got time for on this episode of Lost in Science. Thanks for tuning in and joining us. Lost in Science is recorded at the studios of 3CR in Melbourne and broadcast across Australia on the Community Radio Network with the financial assistance of the Community Broadcasting Foundation. If you want to talk back to us, you can get in touch. We have a Gmail account, lostinsci@gmail. You can also find us on Twitter and on the Facebook. And if that's not enough Lost in Science for you, you can always tune in again next week, where the team will once again get Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.